In this video I will be attempting to repair this. It's a print carriage from an Olympia ESW 100-KSR electronic typewriter. And this is a fairly common failure on these, I believe, and this gear has failed. The bottom end of it has snapped off. This normally is a bit longer than this and fits into the top of this part, and they should rotate together. This fits on top of a drive motor, which is this motor here, and it is responsible for advancing the ribbon each time the typewriter prints a character. But the bottom end of it has kind of just disintegrated, and it's just a collection of small pieces of plastic. It doesn't appear to have actually broken. It looks more like it's kind of degraded, the plastic's degraded, and it's just fallen apart. So I need to do something about this. And you probably can't see it very clearly, but this is a gear. It's kind of tall, thin gear. It runs on a post on the underside of the carriage, but as I say, it should engage with this. Now there are some little lobes inside here that this is meant to engage with. It's one of the reasons it breaks so easily, I suspect, because there's not a great deal of plastic. It's fairly thin anyway. But when it's got the cutouts in there, then there's hardly any plastic left, so it's obviously very easy to break, and when the plastic starts to degrade, it's got no strength left whatsoever. Now there are various ways I could go about doing this. I could manufacture one from scratch. As far as I can tell, this is a module 0.3 gear, 30 teeth, and I could make a entirely new part. I'm going to make it out of brass. My only concern in doing that is this spins at fairly high speed, and it meshes with some other plastic gears on the carriage, and made out of solid brass it would have quite a lot of inertia, and if something jams up on the carriage, then it would most likely strip whichever of the plastic gears it was currently trying to drive. So not really too happy at taking that approach. What I'm going to do instead is make a kind of hybrid part. This is in two parts anyway. I'm going to start by machining the bottom of this up to where the gear starts, get rid of this little extension, and then I'm going to try and press out the white plastic bush. Now if I can do that successfully without damaging the outer plastic gear, I intend to reuse this little gear. And what I've done is drawn up and measured this. I've got to estimate it a little bit because obviously the bottom end's disintegrated and I don't have a replacement or one to compare with. But I've drawn it as best as I can and taken all the critical dimensions of the part I want to make. Now this is not the outer dimension of the gear, it's effectively the outer dimension of the white part. I've got the question marks here because I will need to measure that more accurately once I get the white part out. As I say, I've had to estimate some of the dimensions, in particular the overall height. But one thing to bear in mind is that when something like this is designed, it's designed by people. So if you're trying to get an estimate as to a particular part when you don't have one to compare directly, I got something that came close to 26 millimeters, but measuring other parts, it was clear this has been manufactured or designed in imperial units. So rather than using a metric value and rounding it to a metric value, 26 millimeters is of course very close to 25.4, which is 1 inch. So although the length of this overall is fairly arbitrary, it's not that important, people tend to pick specific sizes when they're designing something. It's unlikely that the designer would have picked 0.932 inches, for example. Is more likely to have picked a round inch because it doesn't really matter what size this is. So that's how long I assumed it originally was. That's the dimension I'm actually going to use. If it turns out to be wrong, I'll just have to make another one. It's fairly critical. The other thing that's critical when I come to machine this is I'll have to turn this all in one operation on the lathe. I don't want to machine one end, take it out, turn it around, put it back in, and then machine the other end, because I'd end up with some run out. My lathe is quite big, so it's not that suitable for this sort of thing. I could put a collet in and centre it, but rather than do that, what I'm going to do is just turn it all in one operation. So I'll put the stock into the lathe, turn the entire thing down, bore it out, and I'll do all that in one operation without taking it out. I'll then part it off, and the only thing left to do then will be to mill the two 1mm slots for the recess that engages with the black gear. So it should be a relatively simple turning operation. What I can then do, if I've managed to retrieve this outer gear, is push this onto the outer part of this, so it will sit with the gear on this part, of course. If this does disintegrate, then what I'll have to do is make the entire thing out of a solid piece of brass. Again, make a gear cutter. I generally make gear cutters rather than buying them. I make quite a few gears each year, and it would get quite expensive if I had to buy a new gear cutter. They all seem to be different sizes from the ones I have, so rather than spending maybe £100 on gear cutters, I'll just make one. But it's quite a time consuming thing to do, so I don't really want to do that if I don't need to. And as I said, I'm trying to avoid too much mass on this. If I do go down that route, then what I will most likely do is reuse the plastic bush, bore out the brass so it's got a larger hole, and then press the plastic bush into it, so it reduces the mass and also gives us back the kind of wear pattern that we would have had before. But the first thing is I'll get this machined, get the end taken off, and see if I can actually get that plastic bush out without destroying the rest of the plastic part. Okay, so I've machined off the end of the part. The first part of the plastic just kind of disintegrated rather than machined off, but by the time I got up towards the plastic insert, the plastic had got much harder and it was machining like a more solid plastic. So I think this part is fine. It's just whatever lubricant was used on the bottom end had dissolved the plastic, so hopefully this top part is still okay. So I could then push out the insert, and I now have the part I want, which is the gear part. And I can also now measure the diameter of this, because that will be the outside diameter of our new part. So I can get the calipers, measure this, and it's coming out at 5.3mm. But one thing I find interesting when working on imperial machines is to switch to imperial mode to see what the likely intended dimension was, and as you can see, it's more than likely this was a 0.2 inch part, or 5.3mm. So I'm going to shoot for 5.3mm, and will most likely bond the new part to the gear. I won't go overboard. There's not a lot of torque going through this, and ideally I'd like it to actually start slipping if something binds up, so it will be very weak adhesive. This is really something that forms kind of a friction between the two parts. So I can get rid of the bush. I'll keep that in case I decide to go with plan B, which is to manufacture an entire new part out of a solid piece of brass. And what I'm going to do now is go to the workshop, make this part, and hopefully when I slip this over the top of it, we'll have a new part that I can put into the machine and it will work. Okay, I've made the part that's required, and I haven't tried it yet, so I bored it out to what should be the same size bore as the plastic bush that was fitted, and the outside should be the same as the inside diameter of this part. The bottom end should fit into here. I haven't actually machined the slots in this yet. I want to see if it actually fits before I go to the time and trouble. It's quite time consuming to mill very thin slots. I mean, I could even just cut a slot all the way through, but I want to mill slots in each side, and then that should fit into the top of this gear. but I want to see if it all fits together, as I say, before I go to the trouble of machining the slots. So the first thing is we'll see if this does actually fit up onto here. So it's supposed to fit onto this post, and that is quite a nice snug fit. It's not rocking about, but it turns nice and freely. Okay, so that's the right size for that. Now we need to see if it fits on here. And you probably can't see it, but I left a very slight shoulder at the bottom of this section to stop this sliding down too far. But this should be a fairly nice sliding fit on here, which it is. I won't push it all the way on just yet. I need to make sure this isn't too tight, because the metal will of course expand as it warms up. I don't want it cracking the plastic, so probably about right. It's quite a lot of drag, but it's not tight, so that will be right, and a few small drops of adhesive and it should go on there quite nicely. But it will normally slide all the way down to the shoulder, so that looks right. And once I've got the slots, I can fit this and see if it actually works. Back from the workshop, I've now machined the two 1mm slots into the end of this, and if I've got my measurements correct, this should now engage in this black gear. So the two slots should engage with the lugs inside the gear, which they do, and the two now rotate smoothly. And this should be a sliding fit in here. It's meant to float in here, so it shouldn't be too loose, but it needs to float up and down freely, and it does, so that's looking quite promising. I've roughed up the surface of this slightly with some coarse abrasive paper so that the glue has got something to key on. What I can now do is glue this gear onto the adapter, and I'll glue it on so that the top aligns with the top of the gear, but there is a shoulder on here as well to stop it from sliding down too far. We've already tried the bore, of course. We know that fits onto the post on the carriage. I've made this very slightly too long. It's about 0.2mm longer than it needs to be, and that's to give me a bit of wiggle room if I need to make any small adjustments, because I don't have an intact one of these to compare. So hopefully this will fit. If not, I'll have to reduce the length very slightly. So what I'll do now is get this glued up, and then we'll try and refit it to the carriage and see if it works. Okay, that's the assembly ready to be refitted. It all fits together quite nicely. I've bonded the gear to the new adapter. We've also got a nice bearing surface in here now as well. Fits together quite nicely. It's obviously quite a lot stronger than the original, so hopefully it will last a bit better. But I'll now get this fitted back into the carriage, and we'll have a quick look at it before I refit the carriage to the machine. Okay, we've got the new gear in place, and what I should be able to do now is slot the black gear on top of that, make sure it engages with the splines, which it does. Turns nice and freely, no real friction, and all I have to do now is refit the motor. So there's a slot or a flat on the shaft of the motor, engages with the black gear, and then the three holes in the motor mounting line up with the three studs, refit the circlips, and that should be the motor in place. So I'll just get that done. Okay, you probably can't see it very clearly, but I've refitted the motor, and I've engaged the motor shaft with the black gear, and on top of that is of course our new gear. And when putting the motor in, this bottom bracket needs to be adjusted to make sure the motor shaft spins freely, and it does. So this now spins very nice and freely, no real resistance, and it turns the gears. So you can see it's now rotating the gears if I spin it the other way. So that should now work in theory, so I'm going to get it refitted into the machine, power it up, and we'll see if we're getting any closer to having this typewriter repaired. I've refitted the carriage to the machine, as you can see. I have not yet refitted the ribbon cassette. I want to see if the mechanism works, and when we put the cassette in we can't see it, it covers it up. Before we look at that, just if you do ever need to take these carriages out, it looks like a very complex process, but it's very straightforward. All you need to do is slacken off this bolt. You don't have to take it out, but slacken it off. You can then move this little lever up and out of the way, retighten the bolt so it's out of the way. Same on this side, just slacken off the bolt, move the lever up, and it will disengage with a slot in this main shaft that the carriage runs on. Again, it's easier if you tighten it so it's out of the way. Run the belt off one of the pulleys, and then it will then just unhook at both ends from the carriage, just a couple of little tabs that it's hooked onto. Unplug the connector, it just plugs on just underneath the bottom left of the carriage here. What you can then do is move the main shaft that the carriage runs on to the left, and this end will then lift up. But there's also a lever down here. This is earthed and it runs along the front edge, or the back edge rather, of this metal plate, and there's a kind of a sprung shoe that runs on this metal channel, and you need to disengage it to get past this lip. And there's a lever. If you push the lever in, you can see protruding from the end of the carriage, it pulls that little sprung carriage out of the way. This entire thing will then lift up and you can slide it off the main shaft. It takes literally a minute to get this carriage out, and to refit it you just do the reverse. Okay, so this is now in. I've put a fresh piece of paper in, very optimistically, and we'll now try and power this up. I'll do it without the cartridge in. So it should of course reset, which it does, and if I now press a key, we should see some activity down here. I'm just going to zoom you in so you can see this area. We should also see you've got these two tape drive spool catchers, and there's one here, and you should see that rotate slightly each time I press the key. Well, I'll zoom you in first so you can see what's going on. So if this is working, when I press the key we should see these pink gears kind of spin around. You won't be able to see much of what's going on, but essentially they should rotate the tape take-up spool drive, and before it was doing nothing because obviously the drive was broken to the motor. So I'm going to press the key, be a noise of course. Well, it's looking promising. I can see the tape spool drive moving, so I'm going to try putting the tape back in and see what happens. Okay, so that's the tape in, and if this is working we'll see the tape slowly rotating, but more importantly, if it prints more than one character we know it's working. What will happen if the tape doesn't turn is the first impact will strip all the ink off the tape, and then any subsequent characters won't really show up. So here we go, fingers crossed. And I don't know if you can see, but the tape is actually rotating and we are getting text on the paper. So I'll raise the camera so you can see the paper, and so again I don't know if this is being washed out by the lights. I'll put my hand over it, hopefully you can see that it is actually leaving text on the paper. There is a pot down here on the carriage for adjusting how hard the solenoid impacts to control the brightness, but from what I gather this is a very old tape from what the owner tells me, so I'm not going to adjust that. I think he has a new tape and he can put that in when he gets the machine back and adjust it if he needs to. We'll just try a few more keys. I'll put my hand over the top again so hopefully you can see the text. I can't actually see through the viewfinder whether the text is showing up or not, so hopefully it is. So let's raise this, and I'll raise the camera a bit further. I'll type a few more characters. And hopefully you can see that it is now successfully printing. It's turning the tape drive around. So if I'll just put a clip on here so you can see it actually moving. So I'll type some more characters and you should see it rotate each time I press one of the keys. So as you can see, it turns very slightly each time I press one of the keys, and it is now printing quite nice and cleanly. It's actually printing quite well considering how old this ribbon is, and it is quite clear. The characters are correct. It's printing what I'm actually hitting, which key I'm hitting. So what I'll do in the next video is we'll go back to looking at the serial port. I had started testing that before this part failed. But as you can see, it's a successful repair, and hopefully it will last as long as the original.